Let's create a follow camera script in Unity. Yes, we'll be creating a simple camera follow script inside Unity. We'll also be looking into things like what to do when player is being spawned or changing stuff through code. But we're going to keep things very simple this time, so let's get right into it. So I have a very simple scene here. This is a basic platformer setup with a parallax effect. And we have a player that can simply move left and right, and the player can jump. If you're interested in how I made this, I have a video on it on the top right. And that video explains everything that you need to know about the input system as well. So if you want to know how I made this, make sure to check that out on the top right. So the player can move left and right, but the camera needs to follow. One simple way of making things work is to put the main camera as a child of the player, and let's see what happens. As you can see, it works, but it is way too linear and it's super responsive. But it won't be ideal if the player has some rotation, because the camera would also rotate along with it. Unless it is an important feature of your game, don't do that. So let's get into business. Before we start, I highly recommend looking into things like Cinemachine or other external Unity packages in the asset store, specifically for camera, because in the end that is going to save you a lot of time. And if you're trying to make a commercial game, I highly recommend looking into those things, because a lot of the code has already been done for you and you just have to use it or learn to use it. If you are indeed making a commercial game, I highly recommend checking it out, because that is going to save you a lot of time, and not just for this project but for all your future projects as well. I'm just telling you straight up facts, because ultimately I would be happy if you guys make meta games. If you're interested in Cinemachine or something, and if you want me to make a video on it, please do let me know. Alright, so I'll move the main camera back. We have a player which just uses the player input component to move, and we have a player controller script which I've made in the video that I've mentioned in the beginning. So I'll go to my camera folder, right click, create C# script. I'll call this FollowTarget, and then I'll open it in Visual Studio. So I'll start by removing start and update. Let's start fresh. So to start off, we need a reference to the player or the target that it has to follow. And what it needs is the position of that particular target. In other words, we can just create a reference of the transform property or component of that particular target. So we're going to create a transform. Let's call it target. This is a private variable, but if you want to set it into the inspector, you need to add an attribute called serialize field. And now if you go back to the main camera, open its prefab and then drag and drop the script, you can see that there is a field called target, which is a transform, even though it is private. So you can use this attribute to create a field inside the inspector, just like how it would be when it is public. So we have a target. Now we just need to, make it follow the target. Let's create void update. Now you may be asking, should I use update or fixed update or late update for a follow camera? Is there any specific answer? Well, yes and no. Like, there is no restriction to you to not use update or fixed update. Essentially, you can use any of the three updates, but using late update has significant number of advantages over using the other two. Let me elaborate. Using late update ensures a smoother frame rate because it runs every frame. But the most important thing to note here is that it makes sense to put our code inside late update. And the reason why is we want the camera to follow its target after the target has made its move. Most probably the player moves inside update or fixed update. So if you're using late update, the camera only moves after the player has moved or the target has moved. I hope that makes sense. Another important reason to use late update is to save a lot of time. I've told you before that there is no restriction when it comes to using any of the three updates. It's just that if you're using late update, you don't have to do anything else. If you're using update or fixed update to move the camera, you would have to then change the script execution order. I'll quickly show you where it is. If you're using update or fixed update, you would have to go to edit, project settings, and go to script execution order, and then you'd have to add your player script and your camera script, and then make sure that the follow target script happens at a later time compared to the player controller script. this would work, but it is a bit of work. So ideally, it may not be the best solution. You don't have to use fixed update for camera follow, but it will work. But the downside of using fixed update is that it runs only at fixed frame rate. By default, it is 50 frames per second. So the camera only moves 50 frames per second as well. If you have a faster machine, or if the target hardware is faster, you can actually take advantage of those extra frames by either using it inside update or late update. But if you're using it inside late update, you don't have to worry about anything else. You would only use late update for things like UI or camera follow scripts. So you don't have to worry about script execution order or anything. You can just directly put it inside late update. So we don't need this right now. So I'll just close this tab. So we're going to use late update. So I'll just remove this and then type late update. And inside late update, I'll just say transform.position equals target.position. And if we set that, the camera will directly snap on top of the target, which we don't want, which means that we need an offset of some sort. To create that offset, I'll use serialize field. Since it's an offset, it has to be a vector 3 because we need an offset in all 3 axes, and we'll call this target offset. If you look at the camera now, you can see that there is a target offset, but there is no way to find out the actual offset. But the better solution would be to actually find the offset through code. In order to do that, we can go to start and say if target is not equals null, which means that there exists a target, we can set target offset as transform.position minus target.position. This will give you the offset that you need to add to your position in order to get the target's position. And inside late update, we'll add this target offset. And now we need to select a target and we'll drag and drop the player. And now since it is not null, you can see that we have a very basic linear follow camera. And this actually works exactly like how when the camera was a child to the player. But now the camera is not a child of the player. But as you can see, this is not smooth. This looks a lot linear. So when the player moves, the camera moves at the same speed. But this type of camera follow may be ideal for your game. So if this is what you're interested in, then that's how you do it. So it doesn't feel, natural or cinematic or whatever you want to call it. It doesn't feel nice. So we need to add a bit of smoothness to the way in which the camera moves. We need to add a little bit of lag so that it feels a lot more real. So let's do it. We can't do things like this. All right, I'll just comment this out. Instead, what we're going to do is we're going to set the position equals vector3.smoothDamp. And vector3.smoothDamp is a function that does the exact thing. If you go into Unity docs, you can see that it gradually changes a vector towards a desired goal or a target over time. Note, gradually. That means that it's going to smooth a particular vector. In this case, it's going to be the position vector of the camera so that it reaches its destination or wherever it should be going in a gradual manner. It looks a lot more better. As you can see, it has 6 arguments. So we might need a couple of variables. So the first argument is a vector3 called current. So let's do that. It's a vector3 called current, which is the current position of whatever this is. So it's going to be a transform.position. The second one is a target, and that is the position that we're trying to reach, which is going to be target.position plus target offset. The same thing as here. So this is actually our destination, but we are smoothing our journey with the help of smoothDamp function. The third one is a vector3 called current velocity. But the interesting thing is that it is passed by reference, which means that it's a value that is being sent as an argument, but any changes made on that value will reflect upon the original value, which means that we need an object to store the velocity of the object. So let's make a private variable vector3 called velocity, and we're just going to pass this as an argument. But since it's passed by reference, we need to use the ref keyword, and we can say velocity. We'll need a couple of more arguments. We'll need a smooth time, which is the time it takes to reach the target. So if smooth time is a smaller value, it will reach there quicker. If smooth time is a higher value, it will reach the destination slower. Alright? And smooth time only has an effect when it reaches either ends of the line, assuming the path is linear. You can make this a curve if you want to, but I'm not trying to complicate things because it's a follow camera. It should be linear. So we'll create a serialized field, float, smooth time. I have tested this out and I find a value of 0.5f to be well suited for me. And we have two more arguments. One is max speed and the other one is delta time. These three things are optional because they have default values. So if you don't provide a max speed, it's not going to have any other restrictions on the speed of the object, but it's better to provide a max speed because we can then control the speed of the camera as well. Serialized field, float, max speed, and I will set this to 15 because this is a value that I've tested out. Okay, and I'll provide smooth time and max speed. I'm not going to use delta time because it uses time.delta time, and since we're using LateUpdate, we don't have to worry about it. If you're using this particular function inside FixedUpdate, then you'd have to use time.fixedDelta time, but this would work because we are using inside LateUpdate. Now the best thing about it is that velocity is passed by reference, so we can actually see the velocity of the camera if we are just debugging this value. And this might be useful in some cases. So using smooth damp will give you a lot of advantages this way as well. I'll go back to Unity and you can see that it is a lot more smoother and there is a gradual lag. So we have a very smooth camera follow. Now comes the question, what if the player or the target is spawned at runtime? If the player is not present inside the scene, inside the editor, how can we drag and drop this player transform into this field over here? We can't. So sometimes you may be having a game manager or something that spawns the player prefab at start or at any point during runtime. How can we set this player as the target for the camera? Let's go back into a script, and the way we're going to do is we're going to create a public function. We'll call it switch target, and we're going to have an argument of type transform, and we'll call it new target. As the name suggests, this function just switches the target. So we'll say target equals new target. And that's it. You just need to call this function on your player script, and this should work. I do have a player controller script, and it contains all these things for the movement of the player. And as you can see, I use a fixed update, but the follow target uses a late update. So it doesn't really matter when it comes to late update, right? I'm just going to go to start, and then I'm just simply going to say camera.main. And if you're using camera.main, you need to make sure that your camera has a tag called main camera. If you can't, for some reason, use the camera as a main camera, you can just simply say GameObject.find object of type follow target, and this should work. Since my camera is main camera, I can just simply use camera.main, and the data is already stored. So why not take advantage of it rather than finding it during runtime? And I'll just simply say get component follow target. And then I'm just simply going to call switch target, and the target is going to be the transform of the player. And now if we just set this back to none, the target is none. Note that we don't have a target offset. It works, but you can see here that the camera is snapping to the position of the player because the offset is 0. The reason why the offset is 0 is we are setting the offset at start if the target is not null. So what should we do if the target is null? We'll address that in a moment, but first let's actually set the target on switch target as well. So we'll provide another argument. We'll say bool, we'll call it change offset, and we'll say if change offset is true, then we'll just copy this code and reset the offset again. If you're using this line of code for the third time, then it's better to create a simple local function. And now inside the player controller, we'll need to provide another argument which is going to be true because we need to set the offset at runtime. So if we play, you can see that the target is player and there is an offset that is being calculated. Cool. Now comes the question, what happens if the target is null? Suppose I comment this out and let's see what happens. Alright, if I play the game and if I go to the console, you can see that the variable target of FollowTarget has not been assigned. It means that the target is null, and inside FollowTarget we are putting it inside LateUpdate, and we have a property that uses the position of the target. And since it's null, it doesn't know what it means. So how can we fix this? The easiest way is to use a boolean. And this is actually very useful when it comes to follow camera. So we're going to say bool, let's call it, is paused. And inside LateUpdate, we'll do these things only if it is not paused. When if paused is false, then we do all of these things. Alright. If the target is not null, we simply do these things. But if it is null, which means we go to else. If it is null, we set is paused to true. Now, what would happen if we later want to switch the target? So in that case, we need something to set is paused back to false. Either we can do it here, but the better option would be to create another public function. I'll call it pause follow, and we'll have a boolean called value, and it simply sets is paused to the value. And let's quickly check if the errors come, and I played the game and the console is free of errors, so we fixed that. And if I uncomment this thing, it assigns references but the camera is still paused, so we need to unpause it, and the way to do that is inside the player controller. So firstly I will cache this into a variable called camera follow target, and it's going to be of type follow target, and then I'll simply say camera follow target dot switch target to transform, and the second argument is going to be true. I'll also say camera follow target dot pause follow to false, and that should do the trick. So we can use this pause follow function to pause your follow whenever you want, and it works like expected. So yeah, and we have a working smooth camera which we can then use across our projects. Just a quick mention, this video is going to have a part 2 in which we work upon this existing script that we have and then improve our camera transitions and the way we switch targets and stuff. And we'll be creating a simple intro sequence like this so that it looks good on your game. Especially if you're making a side scroller game or a platformer game, it's something that improves the aesthetics. So we're going to be creating something like that in the next video, so stay tuned, subscribe if you want to. If I already have made it, I'll link it up in the top right. So yeah, just quickly mentioning it there. Now back to the video. This is just a basic follow camera. It's not quite advanced. It does not contain things like noise or any form of padding or anything. But like I said in the beginning of this video, you can use things like Cinemachine. That will save your time a lot. But do that only if you are creating a commercial project. If you are a beginner, then just don't worry about it. You will learn it as you go. And yeah, that's it. I hope this was useful to you. And if you have any suggestion on what I should make next, please do leave a comment down below, and that will really help me. And yeah, so yeah, take care. See you. Bye-bye. And I'll see you in the next video.
Also subscribe.